Before we look forward, I would like to look back briefly. You flew to space during a very different era. When you see Artemis today being described as a return to the moon, what does that phrase mean to you as an astronaut today?
Actually, I flew into space in a period when we look for flags put on the moon, put around the Earth. Every nation wanted to have an astronaut, a cosmonaut on board the space station to mark the presence of that nation into the outer space. Apollo was the same kind of flight, the same kind of program. During Apollo era, each mission, Apollo mission, was a unique event, was not quite a continuity of something studied a long time and so on. During Apollo era, the Americans wanted to be first to put the flag on the moon, first to touch the moon, and to mark this event at the international level, at a global level. Of course, it was a success. But now, at this time, we don't look for flags on other planets. We look for continuity. We look for much more technology. How do you use this technology? How we approach the space flight from a completely other point of view. Sustainability is the key word here. And sustainability doesn't mean individual episodes. Sustainability means continuity in planning a mission, in technology, in living on another planet or another celestial body like the moon. And this is the most important thing now. The moon was never left by specialists from technical point of view. A lot of missions, automatical missions, were sent to the moon, study the moon, send information about the moon and from the moon. But the pause between Apollo program and Artemis program was a political pause because the specialists continue to do things and to develop technologies for reaching the moon at a different level. Artemis means returning to the moon with experience, not with nostalgia. Experience means that during the last 25 years, we reach quite a wide experience flying around the Earth on low Earth orbit, flying on the International Space Station. A lot of experiments, a lot of studies connected with the human body were done on board the space station. You know, the space flights cause a lot of problems, medical problems to the astronauts, a lot of modification in the human body. And we have to learn how to adapt to the new environment, to a space environment, how to make the human body to resist and to stand to all these provocations, medical provocations, during a long space flight. Now the space flights on board the space stations at a regular base take about 6 months. So we learn how to live and how to adapt the human body to a long space flight. Even there are some records, more than 1 year spent on board the space station. It was done in 94, 95 on board the Mir space station. Russian cosmonauts stayed there 438 days, the time that could take a flight from the Earth to Mars and back. It's a long flight. All these things were done in cooperation now, because space without cooperations can't represent a goal in itself. Of course, competition exists anywhere. In the military field, I don't say about it, the competition is the highest level and so on, but in the civilian space, look, the cooperation for exploring the possibilities of the International Space Station, it's at the greatest level. The Russians, Americans, Japanese, Canadians, Europeans, they fly together. They are good friends. They understand each other on board the space station, and they do things together. So this is how do we see now the sustainability and the continuity of approaching the outer space. Of course, if we look back, this new flight, Artemis 2, which will represent the first return of man around the moon, man and woman, because this is the first time crew formed by a woman and also a colored person will fly around the moon. And of course, they will study the behavior of the human body. They will study how the spacecraft, the Orion spacecraft, faces a 10-day space flight around the moon and returning the crew to the Earth. The same thing was done with within the Apollo missions. Apollo 8 was the first space flight with people on board that reached the moon orbit. They turn around the moon, they study how the human body behave, how the technology behave, and return to the Earth. Apollo 9 studied the landing module only around the Earth, how they undocked and docked in the space, and how they could return to the Earth from the moon, but they study all these things around the Earth. Apollo 10 was very close to touch the moon, but their mission was to study in detail all phases of the human flight to the moon. And only Apollo 11, when 20 of July, touched the moon, and the first person from the Earth, Neil Armstrong, and then Buzz Aldrin, they step on the moon. Now Artemis 2 study the behavior of the human body and of the new technology, completely new technology, flying around the moon and returning to Earth. Artemis 3 will be a success. We hope to be a big success because Artemis 3 is planned to touch the moon, and the crew, a human crew, will step on the moon, on the South Pole. It's a completely different environment. It's a completely different place comparing with the astronauts of the Apollo program. They landed around the equator, in different other places, but not on the poles of the moon. The South Pole represents now a big target for all humanity, not only for Americans, for Chinese, for any other who will send technology and people on the moon. Because the South Pole represents a place with many resources that could be used by humanity. I say by humanity because we'll develop infrastructure on the moon. If the Apollo program was planned to just investigate the moon and to return the people and the spacecraft to Earth, Artemis mission, it's a program, a long program that will build infrastructure on moon. Infrastructure that will allow sustainable continuation of the flights and of the exploration, exploitation, and use of the moon at this time.
So they will leave cargo on the moon?
Or they will leave cargo. Of course, in time there will be bases for humans to live on the moon. The moon environment is, of course, not favorable to life. There is no atmosphere, first. Besides that, the space radiation is much higher on the moon than around the Earth and on the Earth. Living on the moon in a completely closed environment for long periods of time will cause, of course, some problems and put some challenges in front of the humanity. Development of new technologies, development of space medicine, all these things will help to build the infrastructure and to live on the moon and to work on the moon. But of course, all these things will give us a huge experience in approaching another celestial body, Mars. The main target of humanity is not only the moon. The moon, it's an experience, is to learn how to live, how to work on another celestial body, but the big target is Mars. Mars, which is a planet, it's like the Earth. It's, I could say, a terrestrial body, if we could say. It has atmosphere, it has seasons, The structure of Mars, it's pretty close to the structure of the Earth. It looks that on Mars it existed a long time ago, millions of years ago, water and maybe life.
Maybe life,
We
yeah.
study now the possibility of discovering some ancestral traces of life on Mars. But all these things will be learned by humanity, having quite wide experience on working on a moon. Moon is much closer to Earth. From Earth to the moon, it takes about 4 days of flight. And back the same thing. From Mars, it's 8 months maybe. It's much farther. And
At the moment, I would say.
At the moment,
yeah.
at the moment, but this is the law of physics.
Yeah.
You can't change the physics.
But we,
So, of course,
we talk about new technologies in view, like the warp.
Okay, new engines,
new
plasma engines, and so all that work longer time, accelerates to a much higher speed, and then decelerate, and could limit the time of flying to Mars and back at 2 months maybe.
Yeah.
But this is something to be studied.
We're not there yet.